Hello, good morning everyone. Welcome to today's class. Okay, we'll continue the yesterday's lesson. That is lesson number lesson number one of module number 5. And in this module, we are dealing with consolidation of soils. I told you consolidation is so we were dealing with consolidation of soils, and consolidation is expulsion of uh, water from the voids. Okay, when the water is expelled out of the voids, obviously the volume is going to decrease, and because of this decrease in volume, the soil is going to settle. The difference between consolidation and compaction: in compaction also we are reducing the volume of the soil and to achieve a higher density, but the difference is uh, compaction is a man-made process, and uh, when you do compaction, you are achieving a soil of higher density, which increases the strength of the soil. But consolidation is a natural process. When you are constructing any structure on top of the soil, because of the weight of that structure, the soil beneath the structure is getting consolidated over a period of years, okay, depending on the permeability of soil. Okay. So as the soil beneath the structure gets consolidated, okay, slowly the soil is going to settle. Okay, the soil won't settle in one day or two. It will take uh, years years to settle. So maybe after some years there is settlement of soil, and there are two types of settlement. One is uniform settlement. Okay, so if there is a uniform settlement, let's say this is your building. Let's assume that this is your building, and we have this is the soil beneath the building. Okay, in uniform settlement, okay, this is uniform settlement. Okay, the whole building settles uniformly. But if there is non-uniform settlement, non-uniform settlement meaning, yes, at some point it has settled by, let's say, 20 centimeter, at other point it has settled by 50 centimeter. If this happens, then uh, if there is a non-uniform settlement, then your building is going to tilt like this. Okay, this tilting may result in the failure of the building. So if there is a uniform settlement, no problem. But if there is a non-uniform settlement, then it is dangerous for your structure. It may be a building, it may be a dam, it may be road or whatever. It may be embankment. So Uh, to find the amount of settlement, we need to um, know the consolidation characteristics of the soil. So consolidation is very important concept if you want to study settlement of the soil. So, so to explain this process of consolidation, we have a mass spring analogy. So, mass spring analogy. So using mass spring analogy, uh, the concept of consolidation can be explained. So first, let us assume we have a spring and a weight. Okay. So this is the spring and we have kept a weight of 10 units on top of the spring and they are in equilibrium. Let the original length of the spring be Z naught. So when we are dealing with effective stresses, I told you total stress that is applied on the soil, it is resisted by effective stresses, that is because of the intergranular stresses, okay, the stress carried by the solid soil particles, and some of the stress is resisted by or carried by water that is present in the pore, which is called as pore water pressure or simply pore pressure. So total pressure is resisted by or it is carried by effective stress and pore water pressure. Pore pressure. So now here the stress due to weight of 10 units is entirely borne by this spring. Okay. So total stress is equal to sigma dash. Sigma dash is the stress carried by the spring. Now we will add 2 more units of the weight to this arrangement. So initially when 10 units was added uh, and the spring was under equilibrium, okay, the length of the spring was Z naught. Now we are adding 2 extra units. So the length of the spring, it is reduced to Z1. So there is a settlement, there is a compression. Now also the entire 12 units of load is borne by the spring. Spring carries the entire 12 units of load. The extra 2 units which are adding, it is also carried by the spring. So whatever load is there, it is carried by the spring. So this is the first case. Okay. So here we have a spring and we are keeping some weight on top of the spring. So entire weight, if you add extra weight, that weight is also carried by the spring. And when extra weight is added, okay, there is settlement. So this is like 10 units. If you compare it to soil, 10 units is like the self weight of the soil. If you are adding 2 more units of weight, that is if you are constructing a structure, okay, this 2 units, this extra weight, it represents the structure. Okay, if you put that weight, the soil is going to settle. But the difference is in soil you also have water, that is pore water. So now what we'll do, we'll take this arrangement, spring and this weight arrangement, and we'll keep it in a cylinder, okay, in a closed cylinder. So let's say here. I'm taking this spring and weight and I'm keeping this in the cylinder which is filled with water. And you also have this wall. This wall is provided here and an outlet pipe is provided. Outlet pipe has this wall. VALV. If the wall is open, the water can flow out. If the wall is closed, the water cannot flow out. So this spring and weight, it is enclosed in a cylinder, and that cylinder, it is filled with water. So the cylinder is filled with water. Now initially 10 units of weight is there, and the cylinder the arrangement is in equilibrium condition. Okay, now when it is in equilibrium, okay, the entire stress is carried by the spring. The entire stress is carried by the spring. Now let the initial length of the spring be Z0. Now the entire length is carried by the spring. Sigma dash indicates the stress that is carried by the spring. So entire 10 units is carried by the spring. Now what I'll do is, before that, this is the position of the walls. If the wall is open, it is indicated by this symbol. If it is partly or partially open, it is indicated by this symbol. If the wall is closed, it is indicated by an arrow mark in vertical direction. Okay. So in the first case, the wall is open, meaning the water can flow out. So here the entire stress is carried by spring. If some of the stress was carried by water, if you apply some pressure on water, the water is going to flow. So here, because no water is flow, even though the wall is open, no water is flowing out, the entire system is in equilibrium, and the total stress is carried by the spring. Now next I will add 2 more extra units. I will close the wall. I'll close the wall and I will add 2 more extra units of weight. Now, had the spring carried the load, the spring would have gone down. The spring would have settled. But the spring cannot settle here. The wall is closed. Okay. And water is not compressible. It is incompressible. You cannot compress water in a closed container. Okay, you cannot compress the water in closed container. So spring, hence the spring also cannot get compressed. So whatever this 2 units of extra weight is added, it is carried entirely by water. Okay, for the spring to carry this load, it has to compress, but the spring cannot compress because the water that is surrounding the spring, it is also incompressible. Hence, whatever extra weight is added, it is entirely carried by the water. Initially, all the 10 units of load was carried by spring. Now I'm closing the wall and I add 2 extra units of weight. Now this 2 extra units of weight is entirely carried by water. Now the water is under stress. Now this stress or this pressure is called as pore water pressure or hydrostatic pressure or hydrodynamic pressure or excess pore pressure, that because that is our excess load. Please remember, after adding 2 units of extra weight, the extra weight or the excess weight, the excess stress is carried by the water, and this pressure, okay, that builds up in the pore water due to the increment in the load, that is 2 units, is termed as excess pore pressure or excess hydrostatic pressure or hydrodynamic pressure. Okay, now this 2 units is entirely borne by water. So this is the second stage. I am adding 2 extra units, and that extra stress due to two units is entirely carried by water. Now, next step, I'll partially open the wall. So you can see here, I'm partially opening the wall. When I open the wall partially, the water starts to flow out. And when the water starts to flow out, okay, some of the stress that was carried by this water is transferred to the spring. And because some of the water is flowing out, now the spring can get compressed. So due to escape of some water, okay, the piston or the spring moves down, the spring is compressed, and hence some of the pressure out of 2 units which was entirely carried by water is now transferred to the spring. So earlier you can see this equation, total stress is equal to this stress carried by spring plus stress carried by water. So out of 12 units, 10 units was resisted or carried by the spring, and 2 units was resisted by the water. Now I am opening the wall and some water escapes out, and hence some of the stress or the pressure is transferred to the spring. So earlier the stress carried by spring was 10. Now due to escape of some water, uh, we have some extra pressure on the spring takes that pressure, and earlier the stress carried by water was 2, and now some of the stress is transferred to the spring. So when some water escapes out, this piston or the weight comes down, spring gets compressed. So some of the water, some of the stress that was carried by water is transferred to the spring. So this is third step. Next, I'll open the valve completely. Now the wall is completely opened. Okay, when the wall is completely open, the water gradually flows out till all the 2 units, till all the stress that was carried by water will be transferred to the spring. Now, after all the stress that is carried by water is transferred to the spring, the system will reach equilibrium. Then all the 12 units is entirely borne by the spring, is entirely carried by the spring. Okay, did you understand this? Initially, the spring carries all the load. If you add extra weight or extra pressure, that extra pressure is carried by the water. Okay, when you allow the water to flow out of the system, okay, slowly the weight that was carried by water is transferred to the spring. And when all the weight that is carried by water is transferred to the spring, the system reaches equilibrium. Okay, did you understand this? Yes or no? If you have understood this, please raise your hand. Okay, so now this mass spring analogy is linked to consolidation. Now, how it is linked? Initially, let's say this is the soil mass. Okay, let's say this is the soil mass. If you consider any single element, so there is some surcharge or weight, self weight of the soil. So that weight is entirely carried by the soil itself. Now, on this soil strata, I'll construct a building. Now, when I construct this building, the weight of the building is the extra stress or extra load. Now, this extra stress or extra load is initially carried by the water that is present in the soil. The water that is present in the soil carries this extra stress or extra load. Now, because soil is permeable, the water gradually moves out of the soil system. When the water gradually moves out of the soil system, the soil gets compressed, the volume is going to decrease, and as the soil is expelled out or dissipated out of the soil system, okay, uh, the pressure is that extra pressure due to the weight of the building is transferred to the soil mass. Transfer. Okay, now this slowly the pore pressure or the excess pore pressure is dissipated, and the soil takes that extra load. Now this happens over a period of many years. So as the water is getting dissipated out of the system, slowly that extra pressure carried by the water is transferred to the soil. Now as transfer this transfer takes place until all the pressure from the water is transferred to the soil. That is when the condition of equilibrium is attained. So, so when there is a pressure increment, please remember this, the, the total pressure is first taken by water. And as the water escapes out of the system, the load transfer takes place from the water to the soil till the soil system is deformed by the soil strata is deformed by the full amount corresponding to the applied stress increment or the applied pressure. Now this consolidation of the soil, it is linked to the mass spring analogy. Now the grain structure, that is the soil solids. Okay, so the grain structure or the soil solids, it is similar to the spring. It is similar to the spring. Next, the voids filled with water, it represents the cylinder that is filled with water. Okay. Next, this valve, it represents the permeability of the soil. When the wall is closed, the water cannot flow. The pore pressure cannot be dissipated. Okay, only when the wall is open, there is dissipation of pore pressure. So this is how this mass spring, this is called as mass spring analogy. Uh, so analogy means it is comparison between one thing, and it is comparison of two things which are similar to each other for the purpose of explanation or clarification. So this mass spring concept is compared to the consolidation process of the soil. So please remember, whenever extra pressure is added on the soil, that complete extra pressure is first taken by the pore water. Okay, and this pressure is called as uh, excess pore pressure or excess hydrostatic pressure or hydrodynamic pressure. So and and later this as the water is slowly expelling out of the voids, this extra pressure is slowly transferred to the soil particles or the soil solid grains. Okay, so as this happens, there is consolidation or settlement of the soils. Okay, so this is mass spring analogy. If you have understood, please raise your hand. If you have any doubts, you can ask. If you have understood, please raise your hand. Or if you have any doubts, you can ask. The important point to remember, when extra load is added, like you are constructing a structure on top of the soil, the entire weight of that structure is carried by the water, and because of that, the water is getting expelled out of the voids. As the water is getting expelled out of the voids, the stress that was carried by the water is gradually transferred to the soil grains. Okay, and because of this expulsion of the water from the soil voids, the soil is getting compressed, settled. So this is the process of consolidation. Okay, so again, I again have class at 12 o'clock. So we'll meet at 12:15. Okay, we'll meet again at 12:15. I'll engage class for only. So we'll again continue.